ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಈ ಒಂದು ಮಾಡ್ಯೂಲ್ ನಲ್ಲಿ ಕರ್ನಾಟಕ ರಾಜ್ಯ ಮುಕ್ತ ವಿಶ್ವವಿದ್ಯಾನಿಲಯ ಸೆಕೆಂಡ್ ಸೆಮಿಸ್ಟರ್ಸ್ ಎಂಎಸ್ಸಿ ಬ್ಲಾಕ್ 1 ಯೂನಿಟ್ 4 ಆ ಒಂದು ಕಂಟೆಂಟ್ ಅನ್ನು ನಾವು ಡಿಸ್ಕಷನ್ಸ್ ಅನ್ನ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಈ ಬ್ಲಾಕ್ 1 ಯೂನಿಟ್ 4 ಅಲ್ಲಿ ನಾವು ಡಿಸ್ಕಷನ್ ಮಾಡ್ತಾ ಇರುವಂತ ಟಾಪಿಕ್ ಯಾವುದು ಅಂತ ಹೇಳಿದ್ರೆ ESR ಸ್ಪೆಕ್ಟ್ರೋಸ್ಕೋಪಿ. ESR abbreviated as electron spin magnetic resonance spectroscopy. ಈ ಒಂದು ಯೂನಿಟ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂತ ಕಾನ್ಸೆಪ್ಟ್ಗಳು ಯಾವುದು ಅಂತ ಹೇಳಿದ್ರೆ ಝೀರೋ ಫೀಲ್ಡ್ ಸ್ಪ್ಲಿಟಿಂಗ್, magneto anisotropy and dipole interaction, kramer's degeneracy, ಅದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಂತ ಕೆಲವೊಂದು ಎಕ್ಸಾಂಪಲ್ಸ್ ಅನ್ನು ತಗೋತಾ ಇದ್ದೀವಿ. ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಗೆ ESR ಸ್ಪೆಕ್ಟ್ರಾ ವ್ಯಾಲ್ಯೂ ಹೇಗೆ ಬರುತ್ತೆ, ಮಿಥೈಲ್ ರಾಡಿಕಲ್ ಗೆ ESR ಸ್ಪೆಕ್ಟ್ರಾ ಹೇಗೆ ಬರುತ್ತೆ, 1,4 ಬೆಂಜೋಸೆಮಿಕ್ವಿನೋನ್ ರಾಡಿಕಲ್ ಆಟಮ್ ಗೆ ಏನು ಬರುತ್ತೆ ESR ಸ್ಪೆಕ್ಟ್ರಾ ನಾವು ಹೇಗೆ ಡ್ರಾ ಮಾಡ್ತೀವಿ, ಮತ್ತೆ ಸಮ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ರಿಗಾರ್ಡಿಂಗ್ ಟು ದಟ್ ESR spectroscopy. Next, ESR in molecular biotechnology, medical biotechnology, classical biotechnology. Again, last ಅಲ್ಲಿ to summarize the unit. ಇಷ್ಟು ಕಂಟೆಂಟ್ ಅನ್ನು ನಾವು ESR ಸ್ಪೆಕ್ಟ್ರೋಸ್ಕೋಪಿಗೆ ಸಂಬಂಧಪಟ್ಟ ಹಾಗೆ ನಾವು ಸ್ಟಡಿನ ಮಾಡ್ತೀವಿ. Dear learners or students, Professor Hendrik Anthony Kramer's given the names that is called Kramer's doublets anta ನಾವು ಹೇಳ್ತೀವಿ. Kramer's theorems ಕೂಡ ಇದೆ regarding to that EP or spectra ಮೇಲೆ. ಯಾವುದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನಾವು ತಗೊಂಡಾಗ ದಟ್ ಈಸ್ ಸಿಂಪ್ಲಿ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಬೈ ಲೈಕ್ ದಿಸ್. ಅದರ ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಪ್ಲಸ್ ಆಫ್ ಇರುತ್ತೆ. ಟು ಡೌನ್ವರ್ಡ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ದಟ್ ವ್ಯಾಲ್ಯೂ ಇಟ್ ಈಸ್ ಇನ್ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಮೀನ್ಸ್ ಮೈನಸ್ ಹಾಫ್. ಎಲೆಕ್ಟ್ರಾನ್ ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ರೆಸೊನೆನ್ಸ್ ಸ್ಪೆಕ್ಟ್ರೋಸ್ಕೋಪಿ ಹಾಕಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ನಮಗೆ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಗಳು ಇರಬೇಕು. ಮೀನ್ಸ್ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ವಾಟ್ ಆಡ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಆಡ್ ನಂಬರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಗಳು ಇದ್ರೆ ದೇ ಆರ್ ಮ್ಯಾಗ್ನೆಟಿಕಲಿ ಅಟ್ರಾಕ್ಟೆಡ್. ಆಗ ನಮಗೆ ಏನ್ ಬರ್ತಾ ಹೋಗುತ್ತೆ ಸ್ಪ್ಲಿಟಿಂಗ್ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಜನರೇಟೆಡ್. ದಟ್ ಈಸ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಸ್ಪಿನ್ ರೆಸೊನೆನ್ಸ್ ಸ್ಪೆಕ್ಟ್ರೋಸ್ಕೋಪಿ. ಇನ್ನೊಂದು ಥಿಯರಮ್ ಕೂಡ ಎಕ್ಸ್ಪ್ಲೈನ್ ಅನ್ನು ಮಾಡುತ್ತೆ ಅದರ್ ದ್ಯಾನ್ ದಿಸ್ ಕ್ರಾಮರ್ಸ್ ಡಿಜೆನರೆಸಿ. ಒನ್ ಮೋರ್ ಥಿಯರಮ್ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ವಾಟ್ ಜಾನ್-ಟೆಲ್ಲರ್ ಥಿಯರಮ್. ಇಟ್ ಸ್ಟೇಟ್ಸ್ ದಟ್ ಎನಿ ನಾನ್ ಲೀನಿಯರ್ ಮಾಲಿಕ್ಯುಲರ್ ಸಿಸ್ಟಮ್ಸ್ ಇನ್ ಎ ಡಿಜೆನರೇಟ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಸ್ಟೇಟ್ will be unable and will undergo distortions to form a system of lower symmetry and lower energy, thereby removing the degeneracy. This is what statement of this ಜಾನ್-ಟೆಲ್ಲರ್ theorem. ಈ ತರ ಥಿಯರಮ್ಸ್ ಗಳನ್ನ ನಮಗೆ ಯೂಶಲಿ ಜನರಲ್ ಆಗಿ 2 ಮಾರ್ಕ್ ಗೆ ಡಿಸ್ಕಷನ್ಸ್ ಗೆ ಕೇಳ್ತಾ ಹೋಗ್ತಾರೆ. Here, what are the major applications of this theorem? transition metal chemistry or in connections with octahedrally coordinated metal ions with high spin D4 configuration and low spin like D7 and D7 configuration. In each of these cases, P2Z orbitals are equally occupied. ಏನಿದು T2Z ಮತ್ತೆ EC ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲ ಆಕ್ಟಾಹೆಡ್ರಲ್ ಅಂತ ಬರ್ತಾ ಇದೆ. ಆಕ್ಟಾಹೆಡ್ರಲ್ ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ ಸ್ಪ್ಲಿಟಿಂಗ್ ಅಲ್ಲಿ ನಮಗೆ 3 ಬರುತ್ತೆ. ಒಂದೇನಿದೆ T2Z, ಇನ್ನೊಂದೇನಿದೆ ನಮಗೆ ಹೈಯರ್ ಇಟ್ ಈಸ್ ಈಸ್. ಇಲ್ಲಿ D4 ಅಂತ ಹೇಳಿದ್ರೆ here high spin ಅಂದ್ರೆ ಏನದು? It is jumping to higher energy level. This is high spin. This is D4 configuration. Next low spin of D7 ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. D7 ಅಂತ ಹೇಳಿದ್ರೆ here 1 2 3 4 5 6 7 low spin. ಮತ್ತೆ D9 ಅಂದ್ರೂ ಕೂಡ ಎಷ್ಟಿದೆ? ಇಲ್ಲಿ 6 ಇದೆ, here 7 8 ಇದೆ, 9. ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕಾಗಿರೋದು ಏನು ಅಂತ ಹೇಳಿದ್ರೆ ಈಸಿ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ D4 ಅಲ್ಲಿ ಈಸಿ ನಲ್ಲಿ ಎಷ್ಟಿರ್ತಾ ಇತ್ತು? ಒಂದು ಸಿಂಗಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇರ್ತಾ ಇತ್ತು. D7 ಅಲ್ಲಿ ಈಸಿ ನಲ್ಲಿ ಏನಿರ್ತಾ ಇತ್ತು? ಸಿಂಗಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತಾ ಇತ್ತು. ಬಟ್ ಇನ್ D9 ಕಾನ್ಫಿಗರೇಷನ್ಸ್ ಅಲ್ಲೂ ಕೂಡ ಏನಿದೆ? ಸಿಂಗಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈಸಿ ನಲ್ಲಿ. ಅದ್ರ ವೇಲಿಯನ್ಸಿ ಕೂಡ ಇಲ್ಲಿ ನಮಗೆ ಬರೆದಿದ್ದಾರೆ. Single electrons or single valency in easy orbitals. In that, D4 in high spin, D7 in low spin, and D9 in that low spin. Here, when we are getting that single electrons, that is ES or active. That is what ES or active. What is the definitions of this zero field splitting? Zero field splitting means it is the removal of spin, microstate degeneracy for system with S is greater than half in absence of an magnetic field. The degeneracy is removed as a consequence of molecular electronic structure and spin density distributions. The zero field splitting causes the magnetic anisotropy and has a profound effect on magnetic properties. It is a very simple definitions of this zero field splitting here. The removal of spin, microstate degeneracy for the system with S is greater than half in the absence of the applied magnetic field. Here degeneracy is removed as a consequence of molecular electronic structure and spin density distributions. What is this? Magneto-anisotropy and dipole-dipole interaction. Here, magneto-anisotropy referred as the non-uniform distributions of magnetic properties in three-dimensional spaces. Once we are going to apply the magnetic field onto that molecule, here non-uniform distributions takes place. That is explained based on this magneto-anisotropy. The two electrons are there here, two magnetic dipoles in two orbitals of different energies. How it is? Two microstates or arises here. One closed cell singlet with both electron in the lower energy orbital. One open shell singlet with an electron in each orbital. Three belonging to the triplet with an electron in each orbital. One closed shell singlet with both electrons in the higher energy orbital. Just we go through that. Next, here like that. The zero field splitting takes place like that. Here, how it is to formation of this zero field splitting. We consider here, it is 3 dimension, x, y, z. When compound it undergoes splitting, here we are getting here Tx and Ty one set and Tz is another set. What is this? Compressed along with that z-axis. We are compressed along with that x-axis. What happened here? Here aligned with x-axis here Tx, Ty, that is one group, and again that is undergo doublet we are getting. Here singlet, here doublet we are getting Tx and Ty separated. That is what to energy state. And this is the spherical Tx, Ty, Tz. Here in another method of this splitting of this in E level, here what happened here? Tx, Ty it is in down, Tz it is in up, means higher energy. Again it is undergo splitting, what we are getting Tx and Ty. This is what splitting of what? Dipole interaction, based on the dipole interactions. Here just we go through that. D and E representations are. D and E are clearly energy terms describing the extent of zero field splitting in axial and equatorial direction respective. Here D is positive for an oblate spin distribution. It is flattening in one direction on compression along the axis. The D minus is representations of this what here prolate spin distributions, that is along elongations in one direction or lengthening of one axis. Here delta E is equal to 0, that is the triplet species with a threefold or higher symmetry and axial symmetry. This is also one of the very important concept regarding your examination. Generally asking here zero field splitting and dipole interactions. This is also one of the important. This is asked in that 2 mark questions. This is in that along with the 2 mark questions. That Kramer's degeneracy. In the absence of spin-orbit interaction, the ground state of any system with time reversal invariance and an odd number of electrons is degenerate because the spin direction is arbitrary. Consider in case of electrons with up and down like that, spin can be considered independently. The energy level of the system containing an odd number of spin particles is at least double degenerate in the presence of pure electric field. The degeneracy is known as what? Here Kramer's degeneracy only. This degeneracy is due to the time reversal invariance and charge conjugation. The Kramer's degeneracy is removed by placing the system in an external magnetic field if by applying magnetic field like that. It is what? Kramer's degeneracy. This is 1 by 2. Here it is what? Here 3 by 2. This is what? Here 5 by 2. Here S is 5 by 2 multiplied forms 3 degeneracy. The blades that are separated from other by energies significantly larger than the air, less than air 0.3 per centimeters in that microwave quantum. What are that? ESR spectroscopy, and what are the apparatus involved in that ESR spectrophotometer? It is a microwave source, the components, resonant cavity, a magnet and power supplied with field control and field sweep, the modulations and detection systems. This is all what that apparatus consists of the components. This is what here representations of schematic diagram of this ESR spectrometer. In this ESR spectrometer, different field strength we have to use here 9 GHz and 32 GHz. In the ESR spectra, transitions occurs at frequencies in the microwave region. Thus, instrumentation for the ESR require microwave source. Here, what are the sources generally we have to use here? Here, Klystron's wall is a powerful source of radiations of a small frequency range. For free radical studies, the klystron is normally operated in the microwave regions of 3 cm wavelength. The klystron's oscillator is generally operated at 950 MHz. Isolator is a strip of ferrite material. It minimizes variation in the frequency of microwaves produced by klystrons. The wave meter is put in between the wave meter and attenuator to know the frequency of the microwaves produced by klystrons. An attenuator is put in between wave meter and a circulator. It has absorptions of elements and corresponds to neutral filter in light absorption measurements. The circular or magic key. From the attenuator, the microwave radiations enters the microwave circulator. In that figure, it is clearly indicates that operations of 4-part circulators which works a balanced bridge. With all advantages of null method in electrical circuits. Like that, this is what 4-part microwave circulator showing the directions of microwave transmissions along the 4 arcs. The resonant cavity. The resonant cavity is considered as the heart of ESR. Please be noted down this because it containing the samples. This is the structure of this resonant cavity. The ESR spectrometer consists of an electromagnet placed around each side of the resonant cavity and provides a homogeneous magnetic field. An electromagnet which is capable of producing steady field from 50 to 5500 Gauss is essential to studying the sample whose Z factor from 1.5 to 6. That crystal detector, the most of the commonly used detector is a semiconducting silicon tungsten crystals which act as a microwave rectifier and converts the microwave power into the direct current output. In that auto amplifier and phase sensitive detector, the signal in the form of direct current received from the detector undergoes narrow band amplifications by the operations of the auto amplifier. In recorder, the signal from the phase sensitive detector and sweep units is recorded by oscilloscope or pen recorder. These are all what here components present in that ESR spectroscopy. This is also expected here 5 mark. Okay, generally it says that to discuss the instrumentations of that ESR spectroscopy, the different parts of that ESR spectroscopy. Next, we'll move on to that how it is work, means the working of an ESR spectroscopy. Here the sample whose ESR spectrum is recorded is placed in resonant cavity. That cavity serves as a very long path length cell in which the waves are reflected to and fro for thousands of times. The microwave produced by the klystron's oscillator passes through the oscillator wave meter and attenuated, and they are received by the circular through arm 1. The microwave power entering into arm 1 is divided into between arm 2 and arm 3. Generally, arm 3 is balancing load if the impedance arm 2 and arm 3 are same. Then circulator is balanced and no power will be received by the crystal detector through arm 4. If the impedance of arm 2 changes due to some ESR absorption by sample, then bridge becomes unbalanced and some microwave power will enter into the crystal detector through arm 4. Next, the detector acts as rectifier and converts the microwave power into direct current. If the strength of the magnetic field around the resonant cavity containing the sample is changed to the value required for resonance, then recorder will show an absorption curve, that is an absorption ESR spectrum, and the absorption curve is obtained by plotting intensity against the strength of the magnetic field and has no fine structures. Like that way, we are going to record that what ESR spectrum. These are all the sample handling. The sample handling is one of the very important criteria in that ESR spectroscopy. Already mentioned, the sample may be in the form of what single crystal, solid powder, or solutions, or frozen solution is usually contained in the tube about 5 meter diameter. A sample volume of 0.015 or to 0.5 ml can be used for sample which does not have a high dielectric current. For the sample with high dielectric constant, flat cells with a thickness of 0.25 millimeter and sample volume of 0.05 molar are generally used. Here, what are the solvents we have to use here? Water, alcohol, and other solvents with high dielectric constant are not generally used in ESR studies because they strongly absorb microwave power. However, where there is no alternative choice of solvent, other than water, alcohol and other high dielectric constant solvents. When a sample is used in the form of a frozen solutions, the best results are obtained if the solvent frozen to form a glass. It is observed that symmetrical molecules do not form good glass. Example, methyl cyclohexane forms good glass while cyclohexane does not. This is what here simulated ESR spectrum of the CH4 radical and simulated EPR spectrum of the CH2 radical OCH3 radical. Now we are going to discuss with some applications regarding to that molecule. Here we consider here 1,4-benzo-semiquinone radical anion has one unpaired electrons having, what is the value? S is equal to plus or minus of this electron interacting with 4 equivalent protons with spin M1 is equal to here plus 2, 1, 0, here plus 1. Plus 2, plus 1, 0, minus 1 and minus 2. What is the ESR spectrum consists of quintlet, the 5 equally spaced lines as shown in that figures like that. Here based on that what here Pascal triangle we are going to write that intensity of that. You know that what is the Pascal triangles here? 1, 1, 1, here 2, here 1, 1, here 3, 3, 1, 1 like that. Okay. Doublet, here triplet, this one. What is here? 4, 6, 4, 1, 1. This is based on the Pascal triangle only we have to do this one. Okay. This is the concept of this. What here? What? The ESR spectra we are getting obtained. In that naphthalene negative ion, in this case, there are two sets. One is alpha and beta, the 4 equivalent protons each. What we are getting here? 4 plus 1, 5. Here 4 plus 1, 5. Totally, how many electrons are obtained here? 25 lines. Next we consider anthracene negative ions. In this case, there are 3 sets of equivalent protons, that is 4 equivalent sets of alpha and beta protons and 2 equivalent sets of gamma protons. Here what we are getting here? 4 plus 1, 4 plus 1, 5. Here 2 plus 1, 3. Here 25. What we are getting here? 25 lines we are getting from that anthracene. Okay. In triphenyl methyl radical, it has 3 sets of equivalent protons. Here alpha and beta consists of 6 equivalent protons each, and set of gamma consists of 3 equivalent protons. The ESR spectrum consists of 6 plus 1, 6 plus 1 here, 3 plus 1. Totally 196 lines obtained. In general, the ESR spectrum of a system where the unpaired electrons interact with n equivalent protons contains n plus 1 lines, and the relative intensities are given by Pascal triangle. Previous I said that. What are the important applications of this ESR spectroscopy? Here all applications of ESR based on 3 aspects. One is that study of free radicals, investigations of molecules in the triple state, and study of inorganic compounds. In that the free radicals, just you go through that, investigations of that molecules and inorganic molecules, and spin labels. What is the concept of spin labels? The group with unpaired electrons can be attracted to macromolecules such as protein and membranes to obtain a great deal of information, obtain their structure. Here, nitro oxides molecules bound to macromolecules are called spin labels. These spin labels are stable molecules that possessing an unpaired to the electron. For example, here dipole is there 2,2, 2, 6, 6 tetramethyl pyperidonyl N-oxyl. The hyperfine structure of ESR spectrum is kind of fingerprint that helps to identify the free radicals present in the sample. The spin labels give very useful information about the molecules to which they are bound. Next, we consider that structural determinations of this molecule with ESR spectroscopy. Here we consider ESR techniques cannot be applied to determine molecular structure because the information obtained from the superfine structures is mostly about the extent of delocalization and Fermi contact interactions. It does not tell us about the arrangement of atoms in the molecule. So the symmetry of the molecule can be sometimes deduced from the sets of equivalent nuclei. Okay. Common ಆಗಿ ನಿಮಗೆ ಇದೇ ರೀತಿ ಕ್ವಶನ್ಸ್ ನ ಕೇಳ್ತಾರೆ ಸ್ಟ್ರಕ್ಚರಲ್ ಡಿಟರ್ಮಿನೇಷನ್ಸ್ ಆಫ್ ದಟ್ ESR ಸ್ಪೆಕ್ಟ್ರೋಸ್ಕೋಪಿ ಅಂತ ಹೇಳಿ. ಓಕೆ, ಥಿಯರಿನೂ ಕೂಡ ಇರುತ್ತೆ ನಿಮಗೆ, ಅಪ್ಲಿಕೇಶನ್ಸ್ ಲೆವೆಲ್ ಅಲ್ಲಿ ಕ್ವಶನ್ಸ್ ಗಳು ಕೂಡ ಇರುತ್ತೆ. ಸ್ವಲ್ಪ ಥಿಯರಿನ ನಿಮಗೆ ಇದೇನನ್ನ ಹೇಳ್ತಾ ಇದ್ದೀವಿ ಆ ಬೇಸಿಸ್ ಮೇಲೆ ನಿಮಗೆ ಥಿಯರಿನೂ ಕೂಡ ಕಾನ್ಸಂಟ್ರೇಟ್ ಅನ್ನ ಮಾಡ್ತಾ ಹೋಗ್ತಾರೆ. ನೆಕ್ಸ್ಟ್, ದ ಅನಾಲಿಟಿಕಲ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ESR spectra. Here Mn2 ions can be measured and detect even when present in trace quantities. The method is very rapid, can be measured in aqueous solutions over the range from 10 to the power of minus 6 to 0.1 molar. ESR method has proved to be rapid and convenient method for determinations of vanadium in petroleum product. The ESR can also be used to estimate copper, chromium, gadolinium, iron and titanium ions. The ESR spectroscopy has been used to estimate polynuclear hydrocarbons, which are first converted into radical cations, then observed in the surface of an activated silica alumina catalyst. In biological systems, the ESR techniques is used to study the variety of biological systems such as leaves, seed, tissues, preparations. It is found that a definite and correlations exist between the concentrations of free radicals and the metabolic activities of the plant material. The ESR has studied the presence of free radical in healthy and diseased tissues. Most of the oxidative enzymes functions via one electron redox reactions involving the productions of either enzyme bound free radical or by a change in the valence state of transmission metal ions. This has been confirmed by ESR studies. Much of the ESR work on photosynthesis has been carried out with photosynthetic bacterium. The oxidations of bacteriochlorophyll in vitro produces an ESR signal. Next, we consider what is that ESR in molecular biotechnology. In that biotechnology, we have to study that here DNA, RNA and protein structures, the activity of enzymes, membranes and glycobiology. These are all what coming under in that biotechnology aspect. This, by using this molecular biotechnology, by using this ESR spectroscopy, we can determine the DNA deoxyribonucleic acids and RNA ribonucleic acids and protein structure. In that, the proteins have different types of proteins are there. Primary structure of proteins, secondary structure of proteins, tertiary structure of proteins and quaternary structure of proteins, and enzymes also studied. In that, the activity of enzyme is also studied under that ESR spectroscopy. In that, the enzymes are, we know that the enzymes are also what proteins that is present in that human systems. We consider ESR can effectively screen potential inhibitor interactions with the enzymes with high speed. Nowadays, ESR is used in the analysis of enzymatic activity of nitric oxide synthetize the main enzymes delivering the nitrogen oxides in biological systems. Next, we consider that membranes. The existence of phospholipids bilayers in biological systems is confusing from the point of view of evolutionary biology. The model of fluid mosaic appears too simple to satisfactorily represents the details of membrane structures and the respective functions. The common view of the architectures of membranes has changed by the recent years or evidence of the existence of structural domains stabilized by membrane proteins in the form of raft. Okay, these are all some applications. Next, in that glycobiology, the spin-labeled sugars, the sugar residues, and spin-labeled components interacting with the sugar applied into basic field of carbohydrates research. The sugar metabolism means in that degradations and transport. The structural biochemistry of glycoproteins and membranes are listed here. The ESR is employed to analyze the process of sugar transport in bacteria. ESR was applied to analysis of influence of diabetes on the properties of erythrocytes, showing the decrease in erythrocytes deformability due to the non-enzymatic glycatations of hemoglobin. The structural investigations often reveals the medical aspect. These are all what important applications regarding to that biotechnology. In that ESR spectroscopy, the classical what here medical biotechnology, ESR in medical biotechnology. These are all applications of this ESR spectroscopy. The activation and transport of drugs. Here, the ESR is useful in several pharmacological investigations like interactions between DNA binding drugs and DNA. ESR may be used to characterize some derived products which act by increasing the level of free radicals and other reactive species produced during light-induced oxidative stress of the cell. In vitro ESR experiments revealed that multimillar liposomes announce the topical delivery of hydrophilic compounds. Drugs used to be more effective when applied in liposomes than in solutions. That imaging, the ESR imaging is a valuable tool for spatially resolved redox mapping of living tissues. The redox status of tumor tissues is significant for understanding tumor physiology and for the determining the aspects of chemotherapy and radiations. Next, applications of ESR spectroscopy on that classical biotechnology. In that plant biotechnology, we consider ESR is helpful even at developing artificial photosynthesis, which is biggest biotechnological challenge for the mankind. The food productions and storage. Commercially, ESR is used to analyze the shelf life of beer and wine. It is based on free radicals generated in beer or wine due to the actions of light or spontaneously during the process of storage, contribute to the degradations and flavor changes of product. The level of free radicals would depend on antioxidants present in the solutions. Therefore, the antioxidants capacity of beer or wine helps to predict stability. Similar approach is applied to other food products such as oil or milk. The ESR measurements revealed also photosensitizing actions of the important milk ingredient, the vitamin B12, which may affect the quality of the product. The ESR also used in food science and the field of hydrations, water diffusions, and small molecule mobility in food systems or sugar water systems used to model much more complicated system. Finally, we summarize that ESR spectroscopy. Dear students, in this topic, we learn the concept of this, what implied the study of paramagnetic substance, most commonly in liquids and solids. The spectrum is obtained on continuous wave ESR by sweeping the magnetic field. The substance are characterized by measurements of the G factors at the center of the spectrum of line splitting due to the hyperfine structures from nuclei with spin I not equal to 0, field splitting, characteristics of transmissions, metal ion complex and other substances which two or more unpaired electrons can be observed in solid samples. The concentrations measurement with the Cw, continuous wave and ESR method are common in other applications. High field and multi-resonance method employed in modern applications improve the resolutions of the G factor and the hyperfine coupling respectively. Pulse microwave techniques are used for the measurements of dynamic properties like magnetic relaxations, but also for spectral studies. From this topic, we have to learn some basic questions for self-studies. Here, how to determine the number of peaks by using that ESR. Okay, some of the example we taken, and the number of peaks in that methoxymethyl radical and cyclopentadiene, benzene dianion, cyclopentadiene anion, anthracene, naphthalene. These are all examples. These are all some important questions regarding to your point of second semester's examinations. Thank you.